Okay, this is geometry, lesson 3, part 1. And we're going to be looking at properties of triangles. So you can describe a triangle by its angle measures, whether it's acute, right, or obtuse. Or you can classify a triangle based on its side lengths, equilateral, isosceles, and scalene. Now, first of all, what technically is a triangle? Three sides, right? That's where the tri comes from. It is a closed figure, so you can't have something like that, even though it has three sides, right? It's got to be closed. Okay, so bang, bang. And then the sum of the interior angles. So if you add up all those angles, okay, so adding up the angles will equal 180 degrees. And those are the three criteria. So again, that's where the name comes from, triangles. There's three angles. Okay. Now, if you have a triangle where all the angles are less than 90. So remember 90 is this one right here. Okay. Completely vertical line connected to a completely horizontal line, 90 degrees. If they are all less than 90, it is called acute. If one of them is 90, it is called a right angle, which we already know that. Obtuse, one angle measure is greater than 90, and it's right here. Okay, so bigger than 90. So just in case you forget, if this is angles, right, from here to here, that's 90. And then keep going, that's 180. And then all the way to here would be 270. And then all the way around is 360. Okay. If you are classifying triangles by side length, if they are all equal lengths, so if you measured this side, this one, and this one, they're all the same, equilateral, meaning equal. Okay? And we can depict that by putting a slash through the side. What that means is those are equal lengths. So if you don't even know what the measurement is, but you know they're equal, you will see a tick through them, meaning they're equal. Isosceles, two of them are going to be the same length. That's why you see the slash through them. And two of the angles are equal measure. Okay? And it will always be these two smaller ones. I mean, you can just tell by looking at it too, right? Scalene, all sides are of different lengths. So here's about three different examples, and no angles are of equal measure. Okay, and right angles will always be scalene. Um, Triangles are useful in construction and manufacturing projects because of their strength and rigidity. They are the strongest shape. In this section, you will look at triangles in use in the real world. Okay, so for example, use the following diagram to answer the questions below. If it ever says what is the length of side BC, what they're saying is from here to here, that whole line. Okay? And they've given us some information. They've said this from A to C is 20. Okay, and it's directly across from angle B, so we call it side B. Over here, that would mean this is 20 because it shows the double, just meaning the same. They could have put a single one, it doesn't matter. Here's an angle 53. Now, we should know if these two sides are the same length, then this angle will also be 53. Okay? And then what we can also do is we can figure out what this huge angle is here, which should be 180 minus 106, which is both 53s, and you get 74. So we know that's 74. Okay, and they told us the height right here of this divider is 16. So there's actually two triangles making one big one. Now it says, what is the length of side BC? Okay. For this, they have the answer on the opposite page, but I'm going to do it below here so that we can keep looking at the triangle as we work through it. So for A, it's going to be 2 steps. If we have to figure out how long this is, what we're going to do is figure out what X is, this little chunk here, and then we're going to multiply it by 2 because it should be divided perfectly in between the two triangles. Okay? Because these lengths are the same. So if there's a cut right in the middle, X will be the same as this piece. And then we'll just times it by 2. So really, we're just going to work on this one right angle here. Okay. Now we could go about it a number of ways. We could use the fact that this side is 16 and this one's 20 and do Pythagorean theorem. Or we could also use hypotenuse and opposite, right? Or sorry, not opposite, but we could use one of these, hypotenuse or opposite and adjacent, one of those combinations. So either those two there, 16 and x or 20 and x, to solve for the unknown using one of the SOHCAHTOAs. So there's a number of things we can do there. I chose to go with Pythagorean theorem. So again, this is our hypotenuse. And then with the Pythagorean theorem, this side here, h and x are both s. So we just get to use the formula hypotenuse minus one of the sides and square root it. And that was in the last lessons. Okay, now s is going to be x, because that's the one we're looking for. Hypotenuse is 20 minus 16 squared, and then square root it. And we end up with 144 under the square root. So remember to square root it because 144 for x doesn't make sense. Again, probably the number one mistake, and we get 12. Okay, so now we know this is 12. So then we're just going to double it. So step 2, BC, B to C, is equal to 2 times x. So we're going to go 2 times 12. And side length BC is going to come out to 24 centimeters. Now, it says classify. If you ever see this symbol, it doesn't mean angle. It means triangle. A, B, C. So what it's referring to is if you went from A and drew all the way to B, all the way to C, that triangle. If they were talking about this other one here on the left-hand side, they would have said triangle A, B, D. Or they would have said A, C, D, or in any order. Okay? So that's how you can tell the difference. It says classify it by angle measure and by side length. Okay, so B, we have two sides that are the same. So that is by angle, or sorry, that's for side length. By angle measure, 74, 53, 53. So they're all less than 90. So it's an acute. And then by side length, we have two sides that are equal. So we have an isosceles. Okay, and on the next page, you're going to see the exact same solution. However, I just chose to do it so we could see the triangle. And that is the end of geometry lesson 3, part 1.